Okay, welcome to this video. This video is going to be slightly different. This is the solution to the binary counter. So this is important because you will use this a little bit, but more so it's important as to understand binary and the very basics of using variables. So here we first start with declaring our LEDs and which pins they're connected to. Now the first thing to note is that the way I've connected them, they're active high. Okay? Your code will be slightly different if they're active low, and I will show you where it'll be different. But for now, we will continue. So these are all our pins, okay, and we've seen this before, but I've also included this counter here, and I've initialized it to 0. So I'm just going to draw this variable over here. The LEDs don't really matter because they don't change, but the counter will be changing, so I do want to draw this so that I can track it. We then have our setup. Nothing new here. We're just declaring each pin as an output. Okay, so all our LEDs are outputs, which makes sense. Now our counter has 0. And if we look at 0 in binary, okay, it'll look like this. I'm just doing the first 8 bits for this, as we're only looking at the first 5 bits anyway. So when we get here, we're going to look at printing out our counter to the screen. Now we have our LED 1, our LED 2, our LED 3, and our LED 4, and our LED 5. And they're going to be in this order like this. Okay, so this is 1, 2, 3, 4, 5. So on here, I want this to be my most significant bit and this to be my least significant bit for this 5-bit number. So I now go here and I want to write to my LED 1, so turn it on or off, and this is going to be based on what I read out of this counter. So I've got bit read and then counter, and then I want to read bit 4. So I go to bit 4, which is this one here. Remember, the bits start from 0 and go to the left. And this returns a 0. So I'm going to write a low on bit 1. So it's going to stay off. I then go to the next line and I want to look at bit 2, LED 2, and I want to read bit 3. So I have a look at this one, and we can see that's also a 0. So I just leave that alone. I don't turn that on. We can see that 3, 4, and 5 will also be zeros. Now, it's important that your LEDs, when you've actually got them lined up, are lined up such that they're in the same order, so that you're looking at them from left to right. If you turn your board around, it will be backwards. Okay, so just keep that in mind. All right. Now we delay for a little bit. Okay, so they'll stay like that, all off for 1 second. Now I've got this if statement here. Okay, and basically this if statement says if counter is 11111 in binary, so all of these 5 are all 1s, then I reset the counter back to 0. Obviously we can see right now it's definitely not 11111. So we go to the else and we have this counter plus plus. Now this is a unary operator that adds 1 to counter. So our counter becomes 1. Okay, and in binary, actually replace that with black. 1 in binary is just 0, 0, 0, 0, 1. Then we go back up to the top of our loop. Okay, I don't know why the brace is missing there. And we go through this again. So for LED 1, we read bit 4, it's off. Okay, so it stays the same. For LED 2, we read bit 3, it's off. For LED 3, we read bit 2, it's also off. For LED 4, we read bit 1, it's also off. But for LED 5, we read bit 0 of our counter, and it's 1. So we get a 1 here. So we now have digital write LED 5, 1, and 1 is high. So we now have one of our LEDs glowing. Okay, so we have one of our LEDs glowing. And we can see that it's the same as our counter. Okay, so we can see what's happening on our counter in binary on our LEDs. We then delay for 1 second. We check if the counter's full, which it's not. So we go to the else and we increment by 1. So 1 plus 1 is 2. So we get 2 here. Now 2 in binary is going to be 1, 0. Okay, because we've got to carry that 1. So we get 1, 0 here. We go back up. LED 1, bit 4 is 0 still, bit 3 is 0 still, bit 2 is 0 still, so these stay the same. However, LED 4, we read our counter and look at bit 1, and we notice that it's a 1. So now this LED will be on. Okay, so this LED here is now on, but we look at LED 5 and read bit 0, and this one is off. Okay, so you can see that our LEDs match up with our counter. We keep going, we delay, we check if it's full, which it isn't, and we go to the else and we increment by 1, and so we get 3. 3 in binary is going to be 1, 1. Okay, and we can see pretty quickly that what we should get is both 4 and 5 glowing. Okay, and if we keep going, we'll eventually get 1, 1, 1, 1, 1. So we'll get 5 ones, and in decimal that is number 31. Okay, and this would mean that all the LEDs are on. Okay, so we delay for 1 second, so the LEDs stay on for 1 second. We get to this point where we check, is our counter equal to 1, 1, 1, 1, 1? Okay, now with this, it assumes that all the leading ones, or all the leading bits, sorry, are zeros. Okay, so we check this and it's true. So we reset our counter back to 0 and we start again. So we get 0 here. And we're back right where we started when we come back up, and all the LEDs will be off. Alright, so that's the solution. Thank you very much.